Assalamualaikum everyone. This is part 2 for Physics Unit 4, January 2019. We are gonna start with section B, number 11. When the aeroplane is cruising, air enters the engine at the speed up to 52. We have our initial speed here and is injected at higher speed, providing the thrust for aeroplane. The mass of the air injected by one of the engines in 1 minute is 34,600. We have our time and our mass. The total thrust provided by the engines is 138 kilonewton, and we have our force. Calculate the speed relative to the aeroplane at which the air is injected by the engines. So now we have to find the final velocity, which is v. We're gonna use the basic formula for Newton's second law. F equals to m v minus u by t. We're gonna subject u as we're gonna find the final velocity. U equal to f into t divided by m plus v. As they have given us the mass for only one engine, but we need the mass for both of them, so we're gonna multiply the mass with 2. Now we're just gonna put all the values here. For force, we have 138 kilonewton. We're gonna convert it into Newton. Then time, we're gonna convert minute into second. Mass, we're gonna write exactly how it is. Into 2 plus 2, 52. The answer is 372 meter second. That's our answer for number 11. 12. In a science fiction film, a spaceship has engines that use antimatter. Helium and antihelium are collided in the engines. Describe the particles making up the helium atoms in terms of the standard quark and lepton model. What does helium contain? Helium contains electrons, protons, and neutrons. What are electrons? Electrons are leptons, and protons and neutrons are both baryons. And what are baryons made from? Baryons are made up of 3 quarks. This is our total 3 marks. You can write the answer in this way. Number B. Calculate the energy released when an atom of helium annihilates an atom of antihelium. Mass of helium atom is this. We're gonna use our great scientist formula of Einstein, E equal to mc square. We need to find the energy. We have our mass, we have our c, which is speed. Mass, we're gonna write 6.64 into 10 to the power minus 27 into 3 into 10 to the power 8 whole square. And our answer is 1.20 into 10 to the power minus 9 joules. Don't forget to mention the unit. Number 13. The aurora borealis, northern light, are colorful visual displays seen above the North Pole of the Earth. They are created by interaction between air molecules in upper atmosphere and charged particles from the solar wind captured by the Earth's magnetic field. The aurora also produces radio wave charges following a circular path. Important point: emit from an electromagnetic radiation at the frequency of their circular motion. Show that the electron with a speed 400 km per second will emit radiation with a frequency about 200 kHz if moving perpendicular to the magnetic field with a magnetic flux density with 0.8 mu Tesla. So basically we have to find the frequency here. So we're gonna use omega equal to 2 pi f. We have no idea what omega is, so we're going to form an equation to find omega. V equal to omega r. We're going to substitute omega equal to V by r. We have the value of omega here, so we're just going to put it in this equation. 2 pi f equal to v by r. We have no idea what r is, so we're going to form another equation to cut v by r. So another equation can be circular path equals magnetic fields, as they are both related to each other. So for magnetic field, we're going to write BEV, and for circular path, we're going to write mv squared by r. These two get cut and we get 1v here. So BE equal to mv by r, BE by m equal to v by r. That's our second equation. You can see this and this are similar. So we're going to equal our equation 1 with equation 2. It will be 2 pi f equals BE by m. We're going to subtract f, so it's going to look something like this: BE by 2 pi m. As we know all the values for this equation, we're just going to put them here. For b, we're going to put 0.8. we need to convert it into Tesla, into 10 to the power minus 6 into 1.6 into 10 to the power minus 19. 2 pi into, we know the value of the mass, which will be given in the sheet, 10 to the power minus 27. And the answer is this. We're gonna convert it into kilohertz because they put it in kilohertz. 190 kilohertz. Our answer is close to 200, so this is it. Number B. Cosmic ray particles entering the Earth's magnetic field follow spiral paths through the atmosphere. In region of the North Pole, their magnetic field is vertically downwards. The diagram shows an electron entering a section of uniform magnetic field. Explain why. The electron follows a clockwise spiral path downward as seen from above. So let's assume this is our POV, and we are seeing an electron is coming from this path and is going spiral downward in this way, clockwise direction. This is clockwise and this is electron. So as we know, this is a velocity, and velocity have two components. One is horizontal, another is vertical. So when the horizontal component is perpendicular to the magnetic flux line, electron will experience a force. How do we know the electron is experience a force? By Fleming's left-hand rule. And this shows that the force is acting into the page. How do we know it's into the page? As we know that this is the direction of the current, the magnet. So this is north, this is south. We're going to assume this is positive and this is negative. If we use our fingers, we will understand how we got this. So north pole, we are using the first finger to find the magnetic field, north to south, and our second finger to find the current direction, which is positive to negative, and our thumbs shows the direction of the force, which is into the page. As we know, the vertical component here has no effect because it has no downward force. For that reason, it's going spiral in this way. And as we know, the circular path is basically what? Centripetal force. So that's also a point. Number 14. In the UK, the maximum legal speed for a pellet fired from an airgun is 184 meters per second. The diagram shows a suspended block of wood used in a secondary laboratory to determine the speed of an airgun pellet. A pellet fired from the airgun into the block of wood is shown below. The pellet stays in the block of wood. The block of wood and the pellet together then move along the path shown. The maximum height reached is measured. In practical experiment, the maximum height is reached 6 cm. The mass of the pellet, and the block together. Number A. Show the speed of the block of the wood immediately after it's struck by the pellet is about 1 meter per second. So we need to find immediately after. When the ball is here, it's EK, and when the ball is here, is GP. In this diagram, we can see the ball is like in the middle of both of them, so that's why we're equaling it. We're equaling because here we have GP as well as KE, so we're going to equal both of them. Equal them. EK equal to GPE. Half mv square equal to mgh. We can cut the m's out, and we need to find v, so we're gonna subject that to gh. 2 into 9.81. We saw the height here. We're gonna convert it into meter, and our answer is 1.0, which is round up to 1.1 meter per second. Number B. Determine whether the pellet is fired at the speed below the maximum legal speed of 184. This is before scenario. This is after scenario. We will use the conversion of momentum. This is the pellet. This is the block. The pellet is moving, and this is in a stationary state. Here, they both are moving together. So how do we write this? M1 V1. This is not moving, so it's gonna be 0 plus 0, and these are two going together, so we're gonna add up their masses. V. We need to find this. V1 equal to M1 plus M2 into V divided by M1. We know their value, both of them together, pellet and the block of wood, is 150 into this V. We just found it out here. 1.1 divided by the mass of the pellet, which is this 0.93, and the answer is 174.2 meter per second square. Number C. Determine whether the interaction between the pellet and the block of an wood is elastic collision. Your answer should include suitable calculation. We just have to find before EK and after EK, and see whether they match, whether they equal with each other or no. If they are equal with each other, they're elastic. If they are not, they're inelastic. Before it was this, so we're going to use this mass, and we need to convert it into kg. After it was both of them, just 150. As we can see, they don't clearly match with each other, so it's inelastic. Number 15. The diagram shows the parts of the spark coil. A coil of wire P is wound around an iron core. A second coil S is wound around P. The ends of the S are connected to two thin metal rods with a cap G between them, known as spark gap. With the switch closed, there is a current in P. When the switch is open, a large potential difference is produced across S, and the spark is observed across G. Explain why potential difference is produced across the ends of the S. Let's go with the example first. This is primary coil, and this is secondary coil. When the current is flowing into the primary coil, a magnetic field is produced. As we know, primary coil is associated with the secondary coil, So a magnetic field will also be produced in here, which therefore result in flux linkage. This is AC current, and AC current changes direction all the time. So when the current is changing, the magnetic field will change as well, which will result in change in flux linkage, and then which will cause induced EMF. This is how typical transformers work. Let's go back to our question. For this scenario, when the switch is closed, the current flows into the primary coil, producing a magnetic field. As we can see here, primary coil and secondary coil both are associated with each other, so a magnetic field will also be formed in here, and that results in flux linkage. When the switch is opened, there will be slightly difference in current in the primary coil, which results in the change in magnetic field, which therefore cuts the flux lines. And cutting the flux line will cause induced EMF. And hence, this induced EMF will create a spark which is observed across the G. Number B. The potential difference across G is 110 kV. Calculate the time taken for the magnetic flux in the core to decrease to 0 when the switch is opened. Number of turns in S is 42,000. Cross-section area of the iron core is 1.4 into 10 to the power minus 3. Maximum magnetic flux density is 7.4 Tesla. Our key point is to find time taken. As we know, potential difference here, it means the current is induced, and we know a formula for it. Induced current equal to N del phi divided by del t. We need to find time, so del t equal to N del phi divided by E. As we do not have phi here, del phi, we're gonna use a different formula. There's a formula for phi, which is BA. We're gonna use it here, and BA divided by E. N is 24,000 into B 7.4 into area 1.4 into 10 to the power minus 3 divided by E, which is voltage potential difference 110 into 10 to the power 3, because we need to convert this 3.9 into 10 to the power minus 3, which basically is 4 into 10 to the power minus 3 seconds. Next, sparks from when the electric field strength in the gaps exceed 3 into 10 to the power 6 volt per meter, so the air becomes conducting for a short time. Different spark coils produce different potential difference. The maximum sizes of the gap for which a spark is formed for different potential difference are shown in the table. Explain how the data in the table show that the field in the gap is non-uniform. So this is potential difference, and this is maximum gap, which is distance. So we know there's a formula for it, E equal to V by D. For E to be uniform, V should be directly proportional to D. But here they are not directly proportional, as we can see. We need to show it, like explain, and we need to show that they are not uniform. How can we show it? We just have to divide it we have to convert it first to volt and to meter. 0 and 10 to the power 3 divided by 10 into 10 to the power minus 2. 1.1 into 10 to the power 6. For this one, there varies a lot. The gap between them is not proportional to each other, so therefore it's not uniform. Number 2, sketch the electric field in the gap. As we know, electric fields move from positive to negative. We just have to draw that. We have to make sure the arrow is from positive to negative, and draw curvature arrows like this, and from this direction as well. Explain why these experiments were carried out in a vacuum, so we can prevent the alpha particle interacting with the air particle. This is our answer, and the alpha particle may stop before reaching the foil, so we need to be careful about it. That's why it was carried out in a vacuum. Next one. Number B. In one series of experiments, about 1 in 8,000 alpha particles directed at thin gold foil were deflected through angles greater than 90 degrees. Explain how this provided evidence for atoms having a concentration of charge in a central nucleus. Imagine a heavy mass is coming towards you. So in order to deflect it back, you will need to have a greater force on your side. In this case, the alpha particle is heavy and is coming towards you in greater speed. So you will have to need a greater electrostatic force to deflect it back. And such force that is needed to deflect back can be applied only by having a higher concentration of charge. Next one. The angle at which the greatest number of alpha particles was detected for gold was 2.1. The experiment was repeated for other metal foils. The results are shown in the table. Explain the pattern of the table. So as we can see here, the angle is increasing slowly, so does the proton number. So basically, proton number is directly proportional with the angle. As the deflection angle increases, the deflection force also increases. This results in what? Higher the proton number, the higher the charge, which causes higher deflection because of the strong force. You can write the answer like this. The formula we are going to use here is lambda equal to h by p. We need to find p, which is mv. We know the m, so we need to find the v here. So first of all, we need to figure out the relation between them. This is an atom, nucleus positive, electron negative. There is electrostatic force between them, and that force is like moving instant to petrol way. So we're going to equal two equations here. Force equal to k q square because both of them have same charge, by r square equal to mv square by r. Take it car, there's one r. We're gonna subtract v because we need that one. K q square by rm root. K is 8.99 into 10 to the power 9 into 1.6 into 10 to the power minus 19 squared divided by 5. This is the radius. 5.29 10 to the power minus 11 into 9.11 into 10 to the power minus 31. We get 2.2 into 10 to the power 6. We're just gonna put this value here. We know the value of h. Those all data are given in the mark sheet. 6.63 into 10 to the power minus 39 divided by 9.11 into 10 to the power minus 31 into 2.2 into 10 to the power 6. What do we get? 3.33 into 10 to the power minus 10. They are saying it is the circumference is equal to the de Broglie's wavelength. We found the de Broglie's one. Now we need to find the circumference, which is c equal to 2 pi r. 2 pi into, we have the r there. Indeed, the answer are same. So next one, number 17. The circuit shown is designed to test reaction time. The following instruction will test the reaction time of a student. Hide switch 1 from student. Move switch 1 to position 1 and wait until the voltmeter reaches 6 volts. Close switch 2. At random time, move switch 1 to position 2 so the buzzer sounds. As soon as the buzzer sounds, the student should open S2. Use the new voltmeter reading to calculate the student's reaction time. Explain how the circuit works to test reaction time. Okay, when the switch is at position 1, the capacitor charges, because you can see the battery is on this side, so the capacitor will basically charge that time. And when the switch is at position 2, the capacitor stops charging itself. And when the switch 2 is open, like here, the capacitor stops discharging, like completely. You can write the answer like this. When the switch is closed and S1 switch is also at position 2, the capacitor will start discharging, which will result in the buzzer to make sound. Switch 2, you will get a new voltmeter reading, which we can use to find the reaction time by using this formula. You can find the T here to find the student's reaction time. So the formula is V equal to V theta minus T by RC. This is final, and the voltage here was initial. So 0.7 equal to 0.6 E minus T by RC. Our R is, there are two resistance, so we're gonna add both of them, which will be like this, and then multiply with 270. This is mu. We need to convert it into normal farad into 10 to the power minus 6 to use ln. After this, if you put this in calculator, you will get minus 2.21. We shift this there, it will be into 0.0999 minus T. The minus will get cut, and our answer is gonna be 0.21. Sketch the graph of potential difference across the capacitor against time when S1 is moved to position 2 and S2 is closed. So they're saying S1 is in position 2 and S2 is closed. What will happen that time? It will decrease potentially because the switch is closed. The capacitor is discharging at this moment. Next one. Explain how to make the circuit more sensitive for reaction time of 0.2 seconds. You should refer to the shape of your graph. We know the gradient of the graph here is del V by del T. This is the gradient. So if the graph was somewhere like this, starting from here, it would have more potential difference. The gradient would increase compared to the last one, which will result in more sensitivity. You can write the answer like this. We are at last question. The Moscow-Mason factory linear accelerator is used in production of particular isotope for medical use. Strontium 82 is created by bromoring rubidium-85 with protons. Complete the nuclear equation in the process. We know the charge for the proton and the mass number. It's 1 1. For neutron is 1 0. To balance is gonna be here 38, and to balance the mass we're gonna multiply it with 4. Number B. The Moscow-Mason factory accelerated protons up to the energies of 160 megavolts before colliding them into rubidium. The first 100 mega of electrovolt is supplied using a LINAC with drift tubes as shown. Explain how the LINAC accelerates the proton. Here, these are the drift tubes which have opposite charges. If this is positive, this is going to be negative. Let's draw a bigger version. If this is positive, this is negative. This is positive and this is going to be negative. Because of their opposite charges, they're going to create an electric field, and that electric field exert a force on the proton which causes it to accelerate. And when the photon is traveling through the tube, the charges reverses. Like when the proton is here, this charge will become negative, and when it goes to the next one, it will turn that one into positive. And that's how the journey goes on. You can write the answer like this. Next one. The diagram shows the part of the path of proton in LINAC. Point A and point B are at center of two successive gaps between the drift tube. The AC supply has a frequency of 198 MHz. The average kinetic energy of the proton moves from A to B is 2.0. Calculate the distance from A to B. You may assume the proton speed is non-relativistic. First of all, we're going to create an equation which links with other equations. Our main equation is S equal to V into T. S is what? From point A to B. We're going to find it. For V, EK, because we can convert this into joules. And for time, we can use T equal to 1 by F because we have frequency here. First of all, we're going to find V. EK equal to half mv square. V equal to 2E by M. We have already to make sure to convert it. By converting it, we get this. And M is 1.67 10 to the power minus 27. We get 1.96 10 to the power 7. Okay, now we have to find time. Time is equal to 1 by F. 198. We can keep it that way because we're keeping this one in mega, so we can keep that in mega as well. 5.1 into 10 to the power minus 9. This is AC supply, so it's a full circle. We don't need full of it, we need half, so we're going to divide it by 2. We're going to divide it by 2. Okay, now we're going to use this. S equal to V into T. Our V is this and our T is this. The answer we get is 4.9 centimeter. Last question. When the first LINAC were made, the maximum frequency for the AC supply was about 7 MHz. Suggests why it is an advantage to use a much higher frequency than this. Why it is advantage to use higher frequency? If you use higher frequency, the time between the acceleration section will be smaller. This is acceleration section. The time for this will be much smaller, and so it will be possible to reach greater speed with the same length. You can write the answer like this. So we are done with section B. That's all for this paper.